Good morning, everybody. Happy Thursday. Welcome back to another Facebook Live on the Environmental Learning Centers of Connecticut Facebook page. We're down here this morning on the Indian Rock Nature Preserve in the Terra Lab. And today's topic that we're going to cover is watersheds. So we have a big model in front of me. This is called an Enviroscape, courtesy of the Bristol Water Company. And we use this a lot when we invite school groups over to the Bristol Water Company to talk about where they get their drinking water from. So that's what I would like to do today, is kind of a version of that program so everybody can know where their drinking water comes from. So the first kind of question that we have is, where is our drinking water? Where can we find it? And our model kind of gives us some clues, but we can also think about when we go outside into our local outdoor spaces, where is this drinking water? Well, it's in streams, lakes, rivers, reservoirs, wells, aquifers. There's loads of different resources where we get our drinking water. And then that's kind of where it's stored, but then we've got to ask, well, how does it get there? And kind of like today, on a nice cloudy, dreary, rainy day, it's going to be rain. So when rain comes down, it's going to be pulled across the land by gravity, pulled down. It's going to be runoff, or it's going to go directly into those sources of water when it rains. So that's kind of where our water is and how it gets there. But what we're going to focus on today is our watershed. So a watershed, using our model here to kind of get this idea, is a watershed is an area of land. So when it rains, the water is moving across the land, running or shedding across the land, watershed, and it's being pulled down by gravity, and it's entering sources of water. So we see some sources of water here. We've got some rivers, streams, and it's going to go into a larger body of water, like a pond, lake, or reservoir. Okay, so when it rains on the watershed area, gravity is gonna pull it down into sources of water like rivers or streams, and it's gonna run down into a larger body of water like a reservoir, lake, or pond. And that's where we're gonna access it. And the cleaner the water is, once it's in the reservoir, once it's in that source where we're gonna then take it, the cleaner it is when it gets there, the easier it is to clean, further for us to drink, so it's nice and safe, and also the less expensive it is to clean it. So then we kind of start to ask the question, well, how do we make sure it's clean, or clean enough, or less dirty, we'll say, when it gets to the reservoir. So then when it is being taken care of at a water company, it's less expensive to clean. So generally we start to have words pop up on our mind, such as pollution. We want to make sure that the reservoir is less polluted. Okay, so pollution, a pollutant is anything that's kind of introduced to, it could be anything really, it doesn't have to be a body of water, it could be a field, it can kind of be any environmental space. It's just an item that's introduced to the area that's going to cause some sort of damage. It's a contaminant. And you can think pollutants can be anything from garbage. So you have a snack and there's no garbage can nearby, so you think, oh, maybe I'll kind of drop this and maybe the wind carries it along down, and then it enters into a storm drain and then it's carried that way. A pollutant could be when you put on a bunch of sunscreen and then you go into the ocean when you're hanging out at the beach, or it could be those kind of stereotypical pesticides, fertilizers that we think of. So pollutants can kind of be anything that's introduced that's going to have the potential to cause damage, whether it's to plants or animals or to the components of the soil. It can really be anything. So on our watershed here, let's identify some key features. It's kind of got a town set up, like your general town. We have a farm, So we've got kind of an agricultural field as well as some animals. So we've got some little cow models. So we've got some plants and animals growing on our farm. We have an old factory in the back here. We have a golf course. Of course, we've got a highway running through our town. We've got a sewage treatment plant. So when you flush your toilet, it's got to go somewhere and get treated. We have a neighborhood. And then back here, we kind of have a construction site, one of those areas where you see big mounds, a storage site of like gravel and dirt, a construction site over here. So general, really common features that you're going to find in your town that we have here on our model. And pollutants that eventually end up in our reservoir with our drinking water are going to come from all different types of sources. And we have two main kind of categories of pollutants that we're going to talk about. The first category is point source pollution. So point source, if you think about the word point source pollution is when you can physically point to a feature, like say our factory back here. If I'm pointing to the factory, we can tell, we know a pollutant is coming from that factory. We can point to it, it is definitely coming from there. So if we think about it, when we look at our model, we have a couple other features that are also point source pollution. If we point to them and say a point that is the source of our pollution, we can point to it. We have a couple different features, like say our golf course here. Golf courses, they take a lot of water, hundreds of thousands of gallons of water to maintain that really lush green atmosphere, all that grass that they're growing, fertilizers to grow that grass, pesticides to keep off a lot of the insects. So we can point to golf courses, right? That's a known pollutant that's coming from that source. We might have dirt runoff from our construction site. We might have, if we point to the farm, we might have pesticides or fertilizers coming off of there. Okay. The other category, non-point source pollution, is kind of more general. You think of it, non-point. You can't, there's no point. You can't really point to a specific source and say, yes, the pollutant is coming from that area. That's kind of like our neighborhood. Okay. Our neighborhood, a lot of people are living there. People are treating their lawns with pesticides, fertilizers. You might not be able to point to, say, the blue house. Yes, the blue house is giving off that fluid. You might. A lot of times you can't. It's coming from the general area. So those are kind of our two different categories of pollutants, point source and non-point source. So across our model here, there's, say, sewage from our sewage treatment plant. There's pesticides and fertilizers on the lawns in our neighborhood. Same with our farm. There's some sludge coming out of our old factory. Fertilizers on the lawn of the golf course. So there's on our highway here, you might have a really leaky car and you have an oil spill out of your car, or general garbage that people are throwing out of their car. So you've got a lot of stuff going on coming from a lot of different places. So everything kind of seems like it's in its spot until natural stuff happens, like rain. Because remember, we've got to get our water. Where does our water come from? And where do we get it from when we're ready to drink it? So it comes from rain. It's going to run across the land, run across our watershed, and go down to our reservoir. So to simulate our rain, we have a water bottle. And as we make it rain, we're going to make it rain all across our town. And remember, as it rains, gravity is going to pull this water down. It's going to go into your local streams and rivers, and it's going to start to run across the land, down through the watershed, where it's going to start to pool, it's going to start to collect in your larger body of water, whether that's your lake or your reservoir. See that our storm has passed. So when we look at our model, everything, we were using some items over here to represent fertilizer and pesticides and dirt, and we were using some water with food coloring to represent our oil spill and our sludge. So as it rained, these items, gravity is going to pull down the rain. It's going to flow towards the path of least resistance. So it's going to hit your streams and rivers and run down to where it's going to be collected in the reservoir. So if we look at our reservoir, it's now kind of a mix of colors. We've got some green and brown. So that's kind of representing, you're able to visualize the pollutants that now have entered your source of drinking water. So that's not to say that you're drinking that polluted water, because remember, the water treatment plant's going to pick it up and clean it so that it is safe for you to drink. But the less dirty it is when it gets there to begin with, the easier it is to clean, and the safer it is for you to drink, and the less expensive it is to clean. So it's kind of better all around if it's not as dirty in the get-go. So then it's kind of this question of, well, how can we help? So if we think back to our two categories of pollutants, we have point source, where we can physically point to a source, that pollutant is coming from that source, or non-point, where it's kind of a more general area, like our general neighborhood. We kind of have different ways where we can help. So if we think to our factory, nowadays factories are heavily regulated. So there are laws in place, there are policies to say yes or no, you can do this on what is the output of your factory. So a lot of times regulation helps with point source pollution. So you can't just dump all your trash out the window. That's kind of your stereotypical image when you think of a big pipe coming out of the back of a factory and it's just dumping a whole bunch of waste into the river and no one's really caring about that. It doesn't really happen anymore because of regulation. A lot of other ways you can help with point source pollution is general education and communication. For our non-point pollution, so more of your general areas, like say our farm, there's still regulation, but a lot of things that help with farms is vegetation. So if you plant, like if you've got your cows here in your pasture, okay, making it so they can't go into the lake themselves where they're going to the bathroom into the water, okay? So maybe you put up a fence or a tree border, vegetation like that. A lot of vegetation with their roots is going to also help stop with natural erosion as well. So not as much dirt is going to be entering the water system, okay? More natural ways you can help with non-point solution is wetlands. So wetlands are really, really important. They're kind of a natural filter in the water. So there's a lot of plants and animals in there that help to naturally filter the water before it hits into your big reservoir or lake. Okay? And then of course, individually, you as a person, you can help by, when you have trash, put it in the proper trash or recycling receptacles. Or if you see trash that isn't your own, also pick it up. It's kind of everybody's responsibility to take care of the water source, but also the forest and your backyard, just all of your local open green spaces. So that is a little bit about our watershed. And I hope we can kind of use this information to kind of think about the bigger picture and how you in your everyday life can help a little bit more to help stop your local water source becoming as polluted before it even gets to that big source. So it's easier to clean, safer for you to drink, and less expensive for you to clean as well. All right, so that's a little bit about our watershed. If you have any questions about how this works, you can always comment below this video or message us on our Facebook page. This is your daily reminder, even though it's a little bit rainy today, that the trails at the Barnes Nature Center are open for your enjoyment. The Barnes Nature Center is open 7 days a week, sunrise to sunset. So you're always welcome to enjoy the trails. We're going to be back tomorrow on Friday for another Facebook Live at 10 a.m. here on the Environmental Learning Centers of Connecticut Facebook page. So we thank you for tuning in today, and we hope you tune in tomorrow as well.